Hello everybody, I am running just a little late because I got nerd sniped. Let me pause, looks like we're live on YouTube, which means Restream is going too. LinkedIn looks like it's up and Twitch is also going, so hello to everybody. Let me pop out YouTube chat here. I don't like this. Hello, David. Sorry, I've gotten distracted today. I'll talk about that in just a moment. Hello, VP Tech Ops. All right. I think that's it. I think I've done everything. I didn't even open my checklist. So, hello everybody. My name is Scott and I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based out in New York City. I work remotely for them, so I'm actually here in Seattle. And it's a cloudy gray day here in the Ballard neighborhood. And I work on CircuitPython. So CircuitPython is an open source version of Python designed for little tiny computers called microcontrollers. Let me show you. Here's one. This is a board design of my own. This chip here is an RP2350. It's a microcontroller and it's a self-contained computer. So it has like, you know, what would be the equivalent of a hard drive plus RAM and a CPU in here. It can do all sorts of stuff. So this is the PCB for my GameBoy cartridge that I respun. I've been doing more hardware than software lately, but now I'm like totally behind in the software world. Yeah, this is a deep dive. It usually lasts about an hour. I got started a couple minutes late, but I will just go over a couple minutes as well. It's usually just me talking about what I've been working on. And I just got back from vacation, and before I went on vacation, I did a bunch of an order of a bunch of PCB designs. So I got that yesterday, which was great because now I can show it on the deep dive. Before I do that, one housekeeping thing is that next week is the 4th of July weekend here in the United States, and I am taking Thursday and Friday off. So I will not be streaming next week, but Tim is available and going to fill in for me just like he did as I was on vacation. So Tim will be doing deep dive on Friday. He also has a regular slot now on Tuesday mornings if you want to check out what Tim's been working on. But then I should be back 2 weeks from now. I think it'll work out. Toddbot says, cool looking board, thank you. And in fact, yeah, that's the broken out piece. So is there anything else I need to, oh, if you want to support me, go to adafruit.com. If you want to join the Discord, which is the middle one here, you can go to the URL adafru.it/discord and go on there. So Mailbag is what I said. So I did a number of designs, and I'll show those off on the stream here. And before I went on vacation, I was gone almost 2 full weeks. And the JLC order that I did like the day before I left came the day after I got home, which was great. I did have to I had my laptop and had to communicate with them about making sure everything looked okay. But yeah, so let's start where I showed. Let's go to the overhead. I think the overhead is the best option here. It should be working. My desk is a huge mess. And my camera is frozen. Maybe we won't do the overhead. I might have to use the front one. Let me just see if I can't poke it. I love that. It was been working so well. And now it's not. Resolution JPEG. No. Well, darn. If I reset it. Problem is that OBS is not always happy with this camera. Okay, well, it disappeared and it's booting up, so maybe I'll be able to select it again. Le Crotel says, hi, I like you guys, but your constant notifications are starting to hit my nerves. I'm turning off the bell. That's up to you. We do stream a lot, so, and they are different streams, so I understand. Hey. Frame rate, leave unchanged. Resolution. Oh. Oh, it worked. It worked, except that it's still frozen. It took one picture. Okay, so let's go back here. We'll do it this way. And I think I have this button, so it stops doing eye tracking. So we'll just do here. Okay, so the first thing that I showed, go away, phone, is this board. So this is the same board I just showed at the start, but I've taken the outsides off. So this is a GameBoy cartridge, and you can kind of see the little outline here. That's meant to be where the original PCB is. But one thing I wanted to do with this new revision is I wanted to make it standalone. So you can put this PCB in the slot. You can put the PCB itself into the slot of the Game Boy. I have not tested that it works. This is another thing on my list. So these are assembled by jlcpcb. I did verify that it comes up as the RP2350 bootloader thing, but I have not tested it besides that. So this is actually originally it is based on this cart here. So this is a version I did like 6 years ago now or something. It's got a SAMD21. It's hand assembled that I did. This is before jlcpcb had assembly, and you can see that I put it in this cart that I've like clipped apart. I did not care about Kelly's Club, and I had to do a PCB that was extra thin. But this is an extra thick one. This is an extra thick PCB, so I don't need the shell anymore. I've not placed any components kind of where the plastic would be, but you can see that I've kind of like designed it hopefully to fit. So it does fit. I have not confirmed that it electrically connects, but I even did the ENIG plating, so the gold plating for the fingers, and I thought they weren't going to do this, but they did. It looks like they did the beveled edge like I asked them to. So this is to make it easier when you're inserting it into the Game Boy. So here's a Game Boy. I don't have batteries in it, but now I can stick this PCB in the back, and I don't know if you can, it's got a little bit of a nice sound to it. Maybe it doesn't fit. I had it in here. It's a little wiggly, so there we go. So I got it in there, and I'm actually not sure. It goes down, I feel like it goes down further than it used to. Actually, we could try it. So how far down did this one go? So this is the original cart. Oh yeah, and it does go down that way too. I mean, that's because the original, you know, it doesn't want anything overhung. But I'm not sure how well the USB will work. Let me just try it here. Yeah, it's a little wiggly to get it aligned right, actually. That means that I could have the PCB on the outside be a little bit wider, just to get it to line up better. And this USB-C cable does work just fine. So, sorry, I don't know French. So yeah, so that's the Game Boy cart. I've not tested it. Let me just show you, I'll show you the features real quick. So the idea with this cart is that you can put CircuitPython on this chip here, and it reads addresses coming in. I can't do it backwards. And then outputs data. And the idea is that you can write Python code on the cart that controls the Game Boy. So it basically emits sequences of instructions to like play a sound or show something on the screen. It's not meant to run like your game logic on the Game Boy. It's meant to just be that like your game logic computes the stuff to change the state of the Game Boy, if that makes sense. And then what we have here is we have boot and reset buttons. This is like handy for the RP2350. This is the flash that stores the program, USB to it. This is a STEMMA QT connector. Again, I haven't tested any of this, but the idea here is that you can hang other accessories off of it. And then this is MIDI in and out. So in and out MIDI, and then this is the opto isolator. So the input is actually isolated from the rest of the board. And there's a lot of space here that used to be taken up with logic level shifters, but the RP2350 can take in 5-volt I/O just fine. I think as long as it's powered, which it is. There's the clock for it, or the crystal. And yeah, this is a logic level shifter so that we can just do 5-volt logic out. And this is one thing I could poke at next week when I'm back in the office. I've confirmed that like the USB enumerates, but I've not done more testing with that. Any questions about the Game Boy before I move on to the next thing? The Game Boy cart. Here it is in a Game Boy Pocket. It's been a long time since I've done Game Boys, actually. And it does work. The original did work in Game Boy Colors as well. This one actually turns on. I have batteries in this one, but we'll see that it doesn't start correctly because we're not doing the right thing here. You can see we're getting power to the cartridge, but not that. Yeah, and I did do a talk on this ages ago around the first version of the cart, but something would happen where it would get out of sync and the Game Boy would crash. And I want to revisit it now that we have the PIO of the RP2s. That'll be much better for this case. And there is actually spare IO that we could do other stuff with. Next up, let's see, should we do the trackball? So here, let me show you. So this is my original trackball. Well, not original, but here's a trackball that I really like. It's called the Ploopy, Ploopy, and this is the left-handed version of the Ploopy trackball, and I really liked it. I was having some trouble with my mousing right hand, which is my dominant hand, so I got a left-handed trackball. This is my favorite. It's open source, but unfortunately this one I actually fried somehow. I had a bad USB hub while I was gone. Oh, Relic SE asked about the Game Boy cart. Was there enough room to add an SD card connector? I didn't actually try it. I did not have time. Maybe we could trade the... Maybe we could fit one of those ones that goes on the surface where all the address lines are, because on the back it's pretty empty. Or we could trade the MIDI spot for SD card. I don't know. Don't I have a micro SD card around here somewhere? I don't know. I was rushing to get it going, so I didn't actually try that. So I will have to look. So this left-handed trackball was the other thing I was doing. And I have a really fancy setup, or really weird setup, where when my hand is on my left hand is on the trackball, I have my right hand being my mouse keys. And I've been having a lot of trouble with my setup. It's been getting like less and less reliable. I can't show you because it's like plugged together, but I've got like a copper tape on my trackball that is connected to a SAMD21 that's doing touch detection, and then runs a signal from the QT Py SAMD21 into my keyboard, and basically presses a key when my hand is on my trackball. And so I want to redo this system, and yeah, I've been wanting the left-handed version. They came out with a V2 of this, but they didn't do a left-handed version of the V2. The V2 uses an RP2040, and I was like, well, if I'm respinning it to make it left-handed, I might as well update it to a 2350 as well. So I did plug that in. So let me show you the board. So this is the original Ploopy V2, and you can see how it's kind of like soldered together here. So the orientation is that like these two are your like thumb. Your thumb goes like that. Can you see it? So it's kind of like that orientation. And then I redid it left-handed. So this is the baseboard for left hand. You can see here that I did the RP2350. This is the A, not the B. So this is the smaller one. I had them place RGB LEDs, and I put a STEMIC UT connector on there as well. I need to get one of these sensors. They're actually like not easy to buy by themselves. So I actually need to desolder one of them and put it here, which I think I can do. And then I haven't taken this out, but here is the like thumb part, the thumb board. So this goes kind of like that or so. And I have to go to the makerspace next week and get that soldered together. But the reason I was late is that the makerspace has 3D printers, but I have not done the training. And I like actually loaded the 3D shell, the new shell, the V2 shell. And it says one print was going to take 6 hours and the other one was going to take 11 hours. And it's like 20 minutes either way, like both ways up to the makerspace. And so the reason I was a little late starting is because I've been browsing 3D printers to buy a 3D printer to have here in the space with me so that I can just like have it running in the space. So I was looking just at the A1 Mini, which I think would be big enough, the Bamboo A1 Mini to be big enough and cheap. And I don't need multiple colors or anything. I'm doing the case. So I'll probably order that after the stream. If folks have tips, let us know. Let me know for I want to print this basically, which I think will fit on the A1 Mini. So yeah, that's on my to-do list. So yeah, I had board designs to start with. So thanks to Ploopy for being open source. And I basically had to like I had to flip it and then put the switches where they belong and then like reroute it all. Relic SE says a 3D printer is a must. Surprised you don't already have one. I use an Elegoo Neptune 3 Plus, which is pretty good, but I have low standards. Yeah, I don't think I'm doing anything super complicated. I used to own a printer bought Metal Simple like 10 years ago, and just like it worked great until it didn't, and I could never figure out why. So one of the reasons I'm thinking about that Bamboo A1 Mini is actually Brent has one too. They're cheap and good enough for what I need, and Brent has one too. So I would have somebody else to help me with it. I did do that. So Toddbot says you can download Bamboo Studio and set it to A1 Mini without having a printer to see if your designs will fit. It looks like it will. P-Bone says, hasn't Bamboo been having issues not being open source with the slicer? I think there has been some issues. I think there has been some issues. I have not followed it, but I think the reality is that there's, yeah, it's just like really good bang for buck. I know I saw Bamboo Studio source, but I don't know the details of like if the slicer is not part of that or that anything. It's just, frankly, I don't know if there's anything else for $200 that can do like print this trackball case and a whole bunch of like other little cases that would be fun to print. But yeah, I would, if you have other recommendations, let me know. And then, so I had those 3 boards, the Game Boy and the 2 boards for the trackball, which made me think, oh, I actually need, either I need to order 3D prints, and I looked at JLC and it was like $35, and like that's without shipping and import, and it would take a while. Relic says, I don't know, that printer is really, really small. That's probably bite you in the butt eventually. Well, yes, but I do actually have the makerspace if I ever need to do something really large. And I also only had so much space here. So as long as like this project fits, I think most of what I'm going to do is going to fit. Like as long as this, and I think I was looking at it and like when I imported it into Bamboo Studio, it fit kind of like just enough, but then I could have done it diagonally and it would fit better. So yeah, I think it's okay. I think it's size-wise, it's okay. And then the last thing, I'm just gonna unplug it. The last thing in this order was the thing that actually was like the reason I was making the order, and that is the hardware in the loop board. So this is version 2 of it. I think I updated the PCB. Yep, so it says version 2 right here. So what changes did I make in this version 2? So the reason that I was interested in this is because, or the reason I did all these PCBs is because I was gone for 2 weeks. And like it takes some time to get stuff back. So in reality, I switched to vacation mode, and now I'm coming back, and now I'm back into like hardware bring up mode. So yep, this is the V2. Here's a V1. So here's the V1, and here's a V2. And you can't see them both. There we go. So what did I change with V2? Well, and this has the tooling rails from JLC still. So what did I change from V2? Well, my friend Jeff pointed out to me that the way that I had done I2C pull-ups wasn't going to work because I essentially connected all of the data lines to each other through the pull-ups. So without that, when I wasn't pulling it up, everything would crosstalk. And so what I've done here is I now have separate I/O expanders. So I ended up needing an I/O expander in the first revision. And then he just said, like, you know what? The simplest thing is probably just to do more I/O expanders. So now I've got 3 I/O expanders. They should be 3 separate I2C addresses, but I've not actually tested that. And these I/O pins then connect to each individual data line so that they're isolated when they're not pulled, but also we can pull them up or down by just setting the I/O expander pins high or low, which is nice. And then the other big change here, if I remember right, is that this side has been changed. So I was like debating how to power it because I'm going to have a bunch of these connected. It's Arduino card. So yeah, so this is a board where you put other boards on it for testing. So for example, here's a V1, but this is the idea. So you put something like, this is a Raspberry Pi Pico, and then you can connect this one over to the USB host, and it's hosted by this ESP32P4, and it can kind of control everything for what this is called the device under test. And then it makes an interface over Ethernet that you can then talk to over your network for doing remote testing. USB to the ESP32P4 means that you can like get debug information and load firmware and stuff on the P4. And then here I had like a place for a barrel jack. This is the boot button. And then I had this complicated, like, I don't know exactly how I want to power it. And I finally gave up on that, and I'm happy I did so far. So if you see over here, it's way cleaner over here, and I actually could label like which row you want for a certain thing, which is nice. So you were right, Lacrotal, you're right about Arduino as well. So there are Arduino headers here and here, and the goal is to use it. I have an example. Here's another example. I actually set up a bunch of these. So here's a dev board that has Arduino headers on it, and here's one hardware in the loop that I fully kind of populated with headers to make sure everything fit. And what you can do is you can actually place it on top. On top. So if I go like this, now I have my hardware in the loop board. It's not here. The Arduino headers it's plugged into this, and you can put it on the board upside down. And you can also see here that like now I have the USB host things connected. So the idea is that these USB lines are kind of in back and you can't get access to them. And then on this side, you can get access to both your network and your USB, which gives you like flashing capability and power. And then this white thing here is a side lit NeoPixel. So that's for like status. So in the V2, I gave up on the idea that I would do power over Ethernet of any form. And that cleared up this space to say like, oh, I'm just going to label them, which is handy when you're doing just like one row of headers. There's still a USB, but now USB is connected it is the only source for power. So I actually swapped the Ethernet jack as well. So the Ethernet jack is one that's like, they have thousands of instead of hundreds of. The USB is here. The button is still here. This is a power LED. This is the NeoPixel equivalent LED. And then down here, I have a lot more. LEDs. 3 of them are from one from each I/O expander to make sure that you have like the right address. And then the USB LEDs I put on this edge as well, because I was in my limited like software side of this. I was always having to look around the back because I had put the LEDs on the back of it previously. So yeah, that's where I am at on this. I'm really preparing. Oh, I just spotted an issue. It's just a silk screen issue though. Looks like I left the old. Oh, you know what? I don't think that's actually old one. I think that's actually correct. This is telling me that these ones. I can't. My brain can't hold this correctly. The X00 is the like I'm on. Those 6 pins there are from expander 0, port 0. So that is correct. That's not a bug. So yeah, that's the hardware in the loop revision 2. And I got 10 of these. So I actually have 20 of these to really start ramping it up. I ordered like a network switch with 24 switches, and I found these IKEA. I have all these IKEA bookshelves around my office that you can't actually see that well. There's one here, but it's not facing you. It's an IKEA calyx, and I have like above me, you can see these cardboard boxes. They're like, I specially ordered them to fit just in these squares of these IKEA bookshelves. But for the hardware in the loop testing, I ordered shelving units to go in there so that I can have like 2 layers or like 1 layer of 2 layers of swirly grids. So 10 devices under test, and then USB on one side and network on the other, to kind of just like keep a wire monster in a cubby for doing testing. So that is most of what I got. Is there any questions about that? My Siri is telling me it's not on the Wi-Fi. I think I actually brought my phone to fix that. I changed the Wi-Fi in here and then I never updated it. Okay, so I see DCD is typing. I do have one last thing from the mailbag. It'll be a quick one. And I know DCD is probably asking a good question, but the last thing I got in the mail, not in the same package, but this is the ESP32 S31 Corvo, which is like an audio development kit. Relic SE says, is this something that Adafruit is planning on stocking, or is it just for your internal use? That is, that is a question for Lamore, whether she's actually going to stock it. But it is all publicly available. The files are. So you're more than welcome to make one, like order one from JLC yourself. I don't know what Lamore's plans are. I haven't actually asked her, but I also do I have a lot of software work to do. Is the software for the board future? Is that for the hardware and the loop board? So I think that I started to dust it off and fix it up. It's the USB IP bridge software. I wasn't getting logging out the USB, and so I was trying to figure that out. But frankly, I rabbit holed on. Yeah, so the software for the hardware and the loop board I've sketched out, and I did enough to validate the V1, but I am not actively using it day to day yet, which is really where I need to get to. There's a lot of different pieces. So the test software is on the other side of the Ethernet. That's right. So the Ethernet is it's a USB transport, basically. Although I'm debating if that's actually the best way to do it. But as it is currently, the idea is that it's USB IP, and then you run PyTest on your device itself. You run PyTest on your computer, point it to a particular IP, and then it can treat it like it's connected. The USB devices are connected to your host computer. So the tests themselves run there. The nice thing about that is that you can then use ESP, IDF, or whatever tooling to flash it, and we don't have to worry about doing flash stuff on the device necessarily. So the idea is that the hardware in the loop board is doing USB IP pass-through, or switching the USB host stuff to USB IP. And then we also have virtual USB devices. So there's a virtual harness, which is controlling GPIO and reading and writing that. And there's also a virtual logic analyzer that are in there too. So the model right now, as I've been sketching it out, is that you have this USB IP bridge with real USB devices and harness or virtual ones, and then the higher level test software still lives on your host device. So yeah, I don't know if we'll stock it. I don't know. I feel like the software needs to get there. We need to start using it daily to really know that it's good. But if you want to get ahead of the game, then you could order it from JLC, or if you're not too far away, maybe I could send you one. Because I do have a few. Yeah, and then the S31. I actually just wanted to pull this up because I forget why the S31 is cool. Here you can see I installed Bamboo Studio. And then this is trying to figure out... Oh, this made a board definition for the GameBoy cart. For board definition for the GameBoy cart for CircuitPython. Because I wanted to start getting it actually booting up, which would be cool. I don't know which one I'm going to work on. I was kind of today I was oh, I should at least plug every one of them in to make sure that they don't puff smoke, and also show up on USB, so that I can there is a potential if I got a design wrong that I have to order a new revision. And so I feel like today I did the smoke test stuff before I was what do I do with the if I'm testing the trackball stuff, I need a sensor, and I actually need to print off the case. So what do I do for that sort of thing? So, let me open. I wanted to look up the ESP32S31. Because it's been a minute since I've looked at this. Dual core RISC-V SoC with high performance multi-protocol connectivity and HMI. I thought I had Wi-Fi too. This bothers me that they have this, they have all these animations. I do like these charts, but they don't just have the chart. Oh, see, there's a Wi-Fi thing there, so let's keep going down. It's got Wi-Fi 6, Bluetooth, Gigabit Ethernet, and 802.15.4, which is like Thread. Let's just pull up the data sheet. Oh, well, here's a list. Dual core RISC-V at 320 megahertz. So this is slightly slower than the ESP32P4, but nothing to sneeze at. It's got half a meg of SRAM. It's got 250 megahertz 8-bit DDR PSRAM. So this is similar to the P4 again. So the way that I'm thinking about this is that this S31 is really a P4 plus Wi-Fi, which is like very, very cool. It's got GPIO, camera, RGB, but not DSI or CSI, which is the P4 does have. Touch detection, USB OTG, only one USB, I think, not two like the P4 does, and then kind of like the normal stuff. And let's look at the data sheet. But it's still quite cool. Oh, concurrent access to flash and PSRAM. So that's not usually the case. On the older ones, they actually like share the data lines between the two. And obviously this is early days. This is pre-release version 0.2. And they have two SKUs, 16 and 32, which is also the like. Have you found any developer boards on DigiKey yet? For the S31, I haven't looked. I didn't see it when I actually did just browse it. This one I got off AliExpress. Espressif actually has an AliExpress store, and I ordered it from there. So it's like it's an official place to get early stuff from them. And I did actually just order a different dev kit for this same chip, along with a couple other Espressif boards from AliExpress today. They have the P4X EV function kit, which has the latest revision of the chip. I've got versions 0.1, 1.0, 1.3, 3.0, or 3.1, and now 3.2 might be the one that they actually officially come out with. The P4 has gone through a lot of revisions, and so I ordered a new one of that because it said that it had the latest revision. So yeah, I got it off AliExpress. The like actual Espressif store on AliExpress. And it took a little while, but again, I was gone, so it didn't matter. It's not high priority. So for this, here's a block diagram. It's a little small. High-powered core, Wi-Fi, Bluetooth. It's so cool that this has Wi-Fi as well. This is such a monster chip. Like dual-core RISC-V, JPEG decoding, parallel I/O. So parallel I/O is what the logic analyzer on the P4 is using. Dance Dance Revolution RAM. Yeah, it's interesting because I think the P4 probably has 16-bit wide single, like SDR RAM, whereas this is dual data rate, but they have the number of data lines they need then. I wanted to look at USB. So there's a high-speed USB and the USB serial JTAG, but there's not two USBs. I don't know what Cordic is. I don't know what that means. This would be high-speed USB and USB serial JTAG would be enough for the hardware in the loop board, but not an, I think it really is nice to have 2 full USBs like the P4 does. 20 megahertz only. I've mostly used ARM-based chips with CircuitPython. Are there any considerations to make when using the RISC-V platform and CircuitPython? I've not looked into it that much. There's certainly like headroom. Like they talk here about having SIMD acceleration for parallel processing. So that is something, that is where you get to architecture specific stuff, is like really, like, I know you've done a lot of audio stuff. E. Brombaugh says, Cordic is a hardware trigonometry coprocessor that can compute sines and cosines. Interesting. I wonder how we would fit that into CircuitPython. How, like, what sort of interface or what use you would have for that. Maybe for like motion tracking stuff, I guess. That's how you would see it. Wi-Fi stuff. It can do soft AP. Bluetooth LE, including LE audio, which is awesome. I would love for us to do LE audio stuff. I actually wonder if there's any talk of Zephyr support. Direction finding, does it have channel sounding? Channel sounding might be BLE6. So channel sounding allows you to do distance measurement. Oh, it has Bluetooth Classic. Bluetooth Classic is good for doing audio with a lot of headphones. And then also Matter. Single precision floating point unit. Look at that. 128-bit data bus with SIMD commands, supported by only one of the cores. In-package DDR PS RAM, which is fine. That's the only way it comes. 2 different types of DMA. Pixel processing accelerator. This is something I want Display.io to start taking advantage of, is these like display accelerators. And I think the way to do it is like switch to LVGL and then it does the accelerator interfacing. Okay, so the Cordic one is on image and audio processing too. USB 2 high-speed OTG. It's great that it's high-speed serial JTAG. Gigabit Ethernet is super cool. The Ethernet on the P4 is only 100 megabit per second. The idea that you can get 1,000 megabit per second from Ethernet is super cool because it's like twice the data rate of what you would get with USB high speed. So like USB high speed is 480 megabits per second, but like 1,000 megabits per second is like much quicker. You could do like a remote Ethernet, Ethernet-based logic analyzer and be able to get data off fast enough, maybe? I don't know how fast the parallel I/O controller can go, but that would be something to look at in here. Any more questions? We have about 15 minutes or so. RF module. So this is also Wi-Fi, and that I have to remind myself, like, this is Wi-Fi as well. It's awesome. Let's see what it says about Cordic. Its core principle is to iteratively approach a target angle by executing a sequence of fixed angle rotations, rotation and vectoring, DMA connection mode. I don't know what it would be used for there. I2S, USB, Ethernet. Okay, how fast can parallel I/O go? Only 40 megahertz. I think we clock the P4 at 80 megahertz, but the data sheet for the P4 might say that it'll only do 40, but I think we'd run it at 80 instead. 16-bit data bus width. Yeah, and it's through the GPIO matrix, which is why the hardware in the loop is really nice for that. So you can, hardware in the loop has, what, 39 pins to the device under test, and you could pick any of those 39 pins for your 16 bits of like logic analyzer capture. And I want to do that for things like, the whole motivation of the hardware in the loop thing was testing proto matter on a bunch of ESP devices, which is a certain bit pattern, and making sure that the devices all do that. So whenever I work on the hardware in the loop stuff, I got to ground myself in the goal is to test. Like that is like my main use case, is like, let's make sure that add some like automated testing for things like proto matter, so I don't have to get out my RGB matrices every time to test. All right, touch sensor, ADC. Oh, it has an ADC and a DAC. Are there any RISC-V CircuitPython downloads? Yes, for sure. So like a lot of the modern ESPs are RISC-V. So the C series, C3, C2, C3, C6 are all RISC-V already. And the H2 are RISC-V as well. The S2 and the S3 are not. The P4 is. And there's variations of RISC-V as well, of different like knobs that are turned on for the architectures. But yeah, pretty much all of the new RISC, like anything after the S3 release, the ESP32 S3, everything after that is RISC-V. Like Espressif is not doing any more extensor-based chips. David asks, so will you build a hardware and software emulation of a Hub 75 matrix? So my plan is to capture the pinout. So the hardware in the loop board will do a logic capture of all the pins. And then I have logicanalyzer.dev that I have not worked on. But I'd love to, it's not what it is. Logicanalyzer.dev. Maybe there's no dash. Yeah, there's no dash. I can't remember my own domain. But yes, so the intent I have is that like at some point you can use this. You wish they were 16-bit. Well, the ESP32 doesn't even have a DAC. Or ESP32P4 doesn't have a DAC, I don't think. It has more on-chip SRAM, but we're doing the parallel capture to PSRAM anyway. I love how their site links you to a thing that is not right. This is the version 1.3 datasheet. Like, if you don't want me to get to that link, then don't link me there. I haven't looked at the H21 yet, or the E22 I can't buy yet. I forget what's cool about the E22. I basically like buy every Espressif chip as I can, because they're so good for CircuitPython. Although some of them don't have the full USB, but they're generally really good. Okay, I was just going to look at the P4, because I don't think it has a DAC. Chip revision. P4 series datasheet. The idea for the PyTest side of the Hub 75 matrix of those things is the idea is that you can, once you have a capture of the logic analyzer, you just write some Python code that validates that like pulses are within the certain spec and all that is what I'm imagining. Like it wouldn't necessarily emulate it, but it would validate it. Yeah. This is even older. I don't know why this, I don't know where the version 3 datasheet is. Maybe they have it as a P4X, no? I wish Espressif would make a successor to the S3 with native USB. That's the S31, I would say. Like the S31 has native high-speed USB and Wi-Fi and BLE and Bluetooth Classic. Like that's what the S31 is to me. I don't remember what the... Oh, the reason I asked is I can search for ARM on the downloads page, but not RISC-V. Yeah, file an issue. I don't know how that works exactly. It should be easy enough to tag them as RISC-V. And this has... Really? Look here. Peripherals. Yeah, but see, so this is cool about the P4 is that it has USB 2, high-speed OTG, and full-speed OTG. So it has two full things. S31, for some reason it seemed bigger, but yay. Yeah, I forget what the E22 is, but the S31 you can actually, like, you can get a dev kit for. I try not to get too excited until I can get a dev kit for something. So this, yeah, this S31 I think is prime candidate as successor of S3. I think that's why they named it that. Obviously. Applications. So this doesn't even, oh, analog signal. Yeah, so this has ADCs, but it does not have a DAC. Let's just go back here and let's do a quick, I want to see what the E22 is. So there's no data sheet for the E22 yet. Ah, it's tri-band Wi-Fi 6E, so it should actually be able to do what? 2.4, 5, and 6? Dual mode Bluetooth and connectivity coprocessor. So this is, again, don't put it in a video. Just show me that's the cool diagram of what's going on. 500 megahertz. It can do 2.4, 5, and 6 gigahertz. PCIe 2.1. So this is really it's a coprocessor. So this is like less likely to be, oh yeah, and it even comes in an M2 module. It's even less likely to be like, this may actually be the first thing we don't put CircuitPython on. It can do Bluetooth Classic and low energy. High-speed host interfaces, PCIe and STIO3. High-performance connectivity engine. So I think, yeah, the E22 is really about, oh, come on. It looks like it's a button, but it's not. 1 megabyte of tightly coupled memory, no flash, no PSRAM. Okay, so this is like your code would need to be loaded again. And it went nowhere. It didn't actually find it. So it doesn't tell us about the E22, but like, I don't think we would use that. Arduino ESP32 is my indicator of readiness. Hi Tyeth, hi David. TCM versus internal versus external flash. TCM is tightly coupled memory. So this is memory that you can read at the speed that the processor runs. But you can see there's no flash or no PSRAM. So I think what would happen is that you would load firmware into RAM. Like there has to be, I guess there's ROM, but I don't know what the ROM does. But like usually you would load your data into RAM when you're using it as you need it. So E22, not likely good enough for CircuitPython because it doesn't, I don't think it has USB either. S31, awesome. And then there's also the HC61. I don't know if I put it in or not. C5, we have support C3, C2, H4, LE audio and direction finding. These H series don't have native USB usually. H21 is, these are like lower power. It does have, okay, so this doesn't have full USB, it just has the USB to serial to JTAG controller. Supports building thread end devices, thread border routers, and Matter. So this is really targeted at Matter. TCM ROM would be instead of flash, and RAM is generous, so you could, yeah, you put the whole firmware into RAM. David says, maybe Espressif has too many products to the point where it's hard to find which to use. I suspect that a lot of these are actually people going to Espressif. Like, and saying like, oh, if only you had this and this and this and this. And then Espressif says, okay, like, we're hearing that from enough people that will make it. I suspect that a lot of what they come out with is driven by that. But I don't actually know. I think the P4 might have been more their desire to just like have a new tier of stuff. Like I bet it's a different process node, and like they hadn't done that high of speed stuff yet. So JP says PyGB cart is looking awesome. Late to the stream. Ah, here it is again. Oh, it's not in there. I do need to test it. I need to decide next week what I'm going to do, whether I'm going to do this or what. Am I going to work on the GameBoy cart next week? I think I'm going to go to the makerspace and at least solder up the hardware in the loop boards next week. I actually need to come up with a plan of like which things I want to test. I think I actually want to test like all of the Espressif line. So I need to be more rigorous about making sure I have that to do. I'd love to just like, if I could get full coverage on the ESP line in the hardware in the loop thing, I think that would be a good place to start. So that's probably what I'm going to do that next week. I don't think I can solder up the, trackball thing yet because I don't have a case. So that's going to have to wait until I get a 3D printer, I guess, so that I can print all that out. But yeah, so that's my tour of Espressif stuff. Relic says, I don't know, the GameBoy cart seems like a fun option to me. I know where my priorities would be. Yeah, I have a meeting with Lady Ada on Monday mornings, and that's usually where it's like I get some clue with her. It's either GameBoy cart or it's the hardware in the loop stuff. Because we're so, I feel like I'm so close. Like I have nothing that I need in a new revision. I should be able to like go up there and really try to get it. Really try to get it to the point where I can use it, frankly, which is kind of a scary place to be at. Yeah, getting it actually like functional and stuff is a big lift still. So I can get distracted by hardware design and then not do that. But hardware is nothing without software. So yeah. Doesn't gaming make the world go round? Although I'm a big fan of hardware in the loop, ideally Picos with ESPs. Ideally Picos with ESPs. I don't know what you mean. But yeah, the Game Boy cart could be a thing of like, maybe I want to do enough software to like confirm that it works, or I don't know. We'll see. I do feel like I need to, like, it doesn't, like, I wonder if it's as sloppy. Yeah, we have a lot of, there's a lot of slop to it. I wonder if we should make it, how much slop does it? Oh yeah, like the cart itself has like, it sits in there easier. But I don't, it's kind of hard to tell why that is. I'm just, sorry. I'm just like, putting this Game Boy cart in this Game Boy and figuring out like there doesn't feel like that much slop to get it in versus like getting this in there. Like obviously this way is going to be sloppy. Well, that wasn't too bad. Yeah, so it might be that I want to test that and make sure that that gets working. And now I realize you're seeing my browser. Any final questions? Oh, add both the Picos and all the ESPs to my hardware in the loop test. Yeah. Yep, I can use the older revisions too, just not quite in the same way. If I can get 10 of those going, I could always order more. You need a clear Game Boy case so you can see inside. Oh, this is another reason to buy a 3D printer. I don't know if John Park is still watching, but there was this case. What was it called? Game Boy Solo? Cart. Is that what it was called? I spelled it wrong. There's a Game Boy cartridge where they have like Lego compatible studs around the outside, and then you put like Legos on it, which I thought was a really neat idea. What one was that? What was that called? Oh, I forget. What was that called? Game Boy Solo Cart Music Audio Player. Oh, that's the other thing. I could rev the Game Boy to be able to do fix the audio. There was another one. I was looking at the Music Boy one. I can't think about it. I blame jet lag. My brain is a little super audio cart. No. Anyway, there was one where you could like Natalie the Nerd. I think. Is this from Natalie the Nerd? icebergtech.xyz? Or is that something else? I had this for a while, but it's a Game Boy pass-through cart. Nanoloop cart. That's what I'm thinking about. How do you do a... Yeah. So this is a Lego compatible on top of the cartridge, which I think is super clever. And like, see, they have these like 3D printed studs in the corners. Like we would have to figure out how to change the design. This is also where I got the idea of like these little tabs. I don't know what these notches are for, But yeah, this is where I was like, oh, that would be a cool way to do it. But is it the same to check with the GameBoy first? I'm not exactly sure what you're asking. Natalie the Nerd. Iceberg Tech. Is this Natalie the Nerd? I think it is. Oh, media recovery. I wonder if they do 8-inch floppies. But yeah, this is what I bought. And they're actually local. Although I'm not sure I've met them. 3D printing store. I don't know. Is that the same person? It's Iceberg Tech. Anyway, let's wrap up. Thank you, everybody, for joining me on this deep dive where I showed you off the PCBs that I've arrived in the mail and now have a mountain of software and validation work to do for. Again, I work for Adafruit on CircuitPython and hardware design when I get the green light. If you want to support me, you can go to adafruit.com, purchase that. Ooh. Any cubic X for $349 for 260 millimeters print space and 4 colors. I've not looked at that one, but the Bamboo A1 Mini is just very tempting at $200. That's like me driving up and down to the makerspace a number of times. Like, money. I was like, yeah, like I could see myself doing 4 iterations, like printing via GLC, and then it's worth it too. So yeah, I'm looking at that. So yeah, Discord, you can go to the URL adafru.it/discord. Thanks to Tim for filling in for me as I was on vacation, and thanks to Tim for filling in next week when I am out for the 4th of July. I said adafruit.com. I said Discord. Thanks to DCD, who usually takes timecodes. And you can find, if you find me on Discord and want a link to the files for any of these PCBs, let me know. They're already up on GitHub. But again, I make no promises that they work. And yeah, have a great weekend, everybody. I will talk to you next week, or 2 weeks from now. I'll see you on the Discords before then. And window cam, cloudy day here in Seattle.